Okay, I will leave these problem solving questions for you to do in class because they require quite a bit of attention. I just wanted to quickly talk about solving. So we can solve with trigonometric equations. Remember, to find other values, we might need to use these ones here because we want to find all of the solutions. So instead of 180 minus or 360 minus, we do pi minus and 2 pi minus. Instead of repeating every 360, we say they repeat every 2 pi, and for tan, every pi instead of 180. Solving equations, how will you know when to use radians? You will see this. So this is essentially the domain, okay? The domain has pi, so the domain is in terms of radians, which means you must use radians. And that's all the instruction that you are expected to know to use radians. So when you see this, you make sure your calculator is in the right mode. That's the first thing you do. Check your calculator. Does it have the R number up there? If not, okay, you're dropping marks that you could easily get. So how do we solve this one here? The sign is on its own. There's no numbers at the front. There's nothing else. So on the next line, we inverse sine. So sine to the -1, we'll call it for now, √3 over 2. And you get your numbers, okay? And that will say to you that 3 theta is what? Well, that will be 60, which is pi over 3. So if you remember my trick from earlier, I will look at my pair here and I will say, do they add up to pi? Yeah, 3 pi over 3 is pi. That's how I can check the symmetries. We're looking at 3 theta, so we should consider up to 6 pi. Why? Because if we don't do this, when we work out theta, we may miss solutions. So I need to add on pi to this. So I'm going to do, so I need to add on 2 pi to this. So plus 2 pi is going to be plus 6 pi, so 7 pi over 3. So you can go like that. You can do the same thing here. So I need to add on another 6 pi. 6 pi, is that correct? Yep. So I should get 8 pi over 3. And then one more time again. One more time for that, and then 1 for that. You're doing this so that when you divide in a moment, you get all your solutions. So there should be 6 solutions. Yeah. So 1, 2, 3, 4, 5, 6. How do you know there's going to be 6? Because think about how many times you sort of repeat over the normal range. 1, 2. And then you're going to think it like a transformation. You're doing it 3 times faster. So you're going to have 6 answers. Questions, you will get exam questions just like this. How many values would there be? How many solutions will there be? Find all the solutions. Again, radians, this one here. This looks like a disguised quadratic. The identity still works. So the sine x is like the sticky term. The cos squared one is easier to change. You change the cos squared to 1 minus sine squared x plus 1 equals 5 sine x. Expand and collect and everything like this. You will get 2 minus 2 sine squared x plus 1 equals 5 sine x. Collect the terms, set it equal to 0. It's generally worth another mark. Okay, and solve. So set it equal to 0. Factorize if you can, and then you can check it with your calculator. Okay. -3, that one there will not be valid. Why is it not valid? Think about a sine graph. Does it ever go down to -3? No. So you'll never get a solution down here. It has to be between 1 and -1, doesn't it? Half, though, pi over 6, and then the symmetry means you'll get 5 pi over 6 because it's just a regular domain. So 5e is what you want to practice there in your book. Make sure your trig is good because you've got 2 chapters of trigonometry coming up. Okay, so this is a perfect time to practice it.